In the last Cyber video, we looked at Morris II, a controlled research demonstration that explored whether unwanted instructions could repeat across connected AI applications. But that raises a more basic question. How can instructions hidden inside an email, document, or web page affect an AI system at all? The answer involves something called prompt injection. Today on Zyber, we're going to explain what that means, why it is different from traditional malware, and why developers are taking it seriously. No attack instructions, no AI apocalypse, just clarity. Let's begin with the simplest part. A prompt is the information, or instruction, you give to an AI. You might ask it to summarize an article, rewrite a paragraph, organize some notes, or find important dates inside a document. In a basic conversation, the user gives the instruction and the AI responds. But modern AI systems can sometimes read more than your question. They may also process web pages, emails, documents, search results, or uploaded files. That means you may not be the only source of words the AI is reading. Prompt injection happens when content changes an AI system's behavior in a way the user or developer did not intend. Imagine asking an AI to summarize a document. The document should be treated as information, but somewhere inside it is another instruction, trying to redirect the AI toward a different task. The AI now has a difficult job. Should it follow the person who requested the summary, or should it follow the words it found inside the document? The problem begins when the system cannot clearly distinguish trusted instructions from untrusted information. There are two broad ways prompt injection can appear. The first is direct prompt injection. That is when someone communicates with the AI directly and tries to change how the system behaves. They may try to redirect its role, override the application's intended task, or convince it to disregard the rules it was given. We are not going to demonstrate what those instructions look like. What matters is the pattern. A person speaks directly to the AI and tries to replace the system's intended direction with their own. The second type is indirect prompt injection. This is especially important for AI systems that read information from outside sources. Instead of speaking to the AI directly, someone places instructions inside something the AI may encounter later: a web page, an email, a document, a file, or another source of online information. The human user may see ordinary content, but the AI may also encounter text designed specifically to influence its behavior. The person who planted the instruction never had to speak to your AI assistant. They simply placed something in its path. That is why indirect prompt injection can be so difficult to notice. Traditional software usually has a clearer boundary between instructions and data. A calculator knows the number being calculated is information, not a command. To redesign the calculator, AI systems are different. They often receive both instructions and information through language. The same flexibility that allows an AI to understand emails, web pages, documents, and conversations can also make trust boundaries more complicated. Language is both the thing being processed and the way instructions are delivered. That makes it harder to separate the two perfectly. You may also hear the word jailbreak. The terms are related, but they are not exactly the same. Prompt injection is the broader problem. It means input causes an AI to behave in an unintended way. A jailbreak is a more specific attempt to make an AI disregard its safety restrictions. So a jailbreak can be a type of prompt injection. But not every prompt injection is trying to bypass safety rules. Sometimes the goal is simply to redirect the AI toward the wrong task. If an AI can only produce text, an injection may lead to a misleading or incorrect response. That still matters. But the consequences can grow when the AI is connected to tools: email, documents, calendars, cloud storage, web browsers, or workplace applications. Reading an untrusted instruction is one problem. Acting on it is a bigger one. An AI answer can be wrong. An AI action can have consequences. That is why permissions and human approval matter so much as AI systems become more capable. Prompt injection is not something developers solve with one perfect filter. Good defenses use layers. First, limit what the AI can access. An assistant should only receive the permissions it actually needs. Second, treat websites, emails, and documents as potentially untrusted information. Third, require human confirmation before important actions. Sending a message, sharing private information, deleting a file, making a purchase. Fourth, check the AI's output before another system acts on it. And finally, test the system repeatedly with defensive security research. The goal is not to assume the AI will never make a mistake. The goal is to design the surrounding system so one mistake cannot do too much. Prompt injection does not mean every AI conversation is compromised. It does not mean every web page contains hidden instructions. It does not mean AI systems have secret intentions. And it does not mean people should stop using AI. It means AI applications need clear boundaries, limited permissions, careful testing, and meaningful user control. This is a design challenge, not a reason to panic. Prompt injection is not really about one magical sentence. It is about trust. Which instructions should the AI follow? Which information should it treat only as data? And how much should it be allowed to do before a human checks? Those are difficult questions, but asking them now helps developers build safer systems before AI becomes connected to even more of our digital lives.
Cybersecurity doesn't have to be scary or complicated. Here in Zyber, we show you how to make it simple, practical, and even a little fun. Stay smart, stay secure. This has been Z. Till next time.